Hey guys, welcome to Code Decode. So today the agenda of this video is to show you how to do fault tolerance in microservices.
In the next part, we will cover API gateways and a way to scale this example of microservice to cloud like AWS. But we are setting a target of 500 likes in this video so as to continue with this microservices and AWS cloud series.
So basically I'm going to cover first thing, which is what is fault. Secondly, we will be seeing how to tolerate that fault, or nothing called as fault tolerance in microservices. Third, what is the way to do fault tolerance in microservices in Spring, which is nothing but Hystrix. We can also use Resilience 4J. And last but not the least, a very important interview question, that while doing the fault tolerance in your microservices, which design pattern have you used? So this is a very important interview question you will be asked in most of the time. So let's quickly get started and understand what is fault, and then we will see what is fault tolerance. So if you would have remember, we had nothing but a vaccination center service, we had citizen service, and we had one method that get all data. When you hit a particular vaccination center service with the ID, I need that I should get all the inputs of vaccination center. So basically, what is the vaccination center ID? So this is what we did, right? We hit the vaccination center with ID. What we got was your details about your vaccination center. So this is the detail about my vaccination center, which is nothing but the ID, center name, and center address. Apart from that, what we also got is we used REST template to hit the citizen service, and we have given nothing but the ID, and what we got as a response is list of all those citizens who are registered to this particular vaccination center ID. So my vaccination center ID was always one in both the citizens. The ID and the name changed. So this is nothing but the data of citizens who are registered to my vaccination center. So this was our agenda, that hitting the vaccination center service, I should not only get the vaccination center detail, but also all the details of the citizens who are registered to a vaccination center. So for that, I've created a diagram for you previously, which is nothing but we had a postman. We hit vaccination center service with postman. This is the vaccination center service. We hit it with a particular ID. As soon as it gets the ID, it gets into its own database, fetch the result of vaccination center data. Then it goes to the REST template to citizen service, get the data out of it and give it back to you. So this is my very user-friendly data we found for the user. So here it's nothing but all the user-friendly data for us. Now the question arises is that what is a fault? Now fault can arise when your citizen service is down. So there are many ways or many reasons because of which your citizen service is down. In my local, to make it down, what I'm going to do is just actually close the server of citizen service. In cloud, you may stop the instance where this particular citizen service is down, or many more things I'm going to tell you when I'm going to cover the AWS series. But right now, for making just a demonstration at local, what I'm going to do is my vaccination center is available, so I can show you. These are my three consoles. Eureka server is on. My vaccination center service is also on. But now I'm going to close my citizen service. So as soon as I close my citizen service, there is a fault. So let me show you how fault looks to us. So this was a very happy response which we used to get when all the services are on. Now I'll tell you how do we generate a fault. So as soon as I close this, now only two servers are on, Eureka service and vaccination center service. So let me quickly hit it now. So you can see my console is printing something, and my actually debug goes into my vaccination center. So as soon as I get into it, my vaccination center is on. That is why I'm getting all the required response of vaccination center. So it says, yes, your vaccination center service is having all the data where the ID is 1, center name is 1, address 1 is 1. As good as the previous one. So we had all our data here. I won't be getting the citizen service. So I was expecting as a user that even if your citizen service is down, at least give me the vaccination center service data. But as soon as you can see, the REST template is not going to hit the citizen service because it is down, and hence a particular error is going to occur. So great, the error has occurred. Let me quickly remove the breakpoints, and you can see that my postman is giving me internal server error. So right when you hit a vaccination center with a particular ID, I was expecting here that even if you don't the citizen service data, at least give me the vaccination center data. But it was not allowed. It was not available. Even my vaccination center data is gone. So this is fault. So what happened is you tried to hit vaccination center service. You tried to get through the vaccination center service. I was successfully able to fetch vaccination center detail. But in the same code, since I'm calling the citizen service, it is not able to call it. The whole data we have fetched is lost, and what we see on the browser or on the postman is not at all user friendly message. It's internal server error. User is like going to cry, what happened? It is not even explanatory. What wrong have I sent here? Is their headers wrong? Is their body wrong? What is wrong with this that I've got this? He won't even actually know that your microservices down. So this is nothing called as fault. So if the fault is clear to you, let's see what is fault tolerance. Fault tolerance is nothing but a property or a way that enables a system, in case our system is related to COVID site, a very small version of that. So enables our system to continue operating properly in the event of failure of some of its component. The component which was failed here was nothing but the citizen service. I was expecting that this system that I have created here is should be fault tolerant, and even if my user service or citizen service is down, at least it should be able to give me vaccination center data. So that is nothing but a fault tolerant system. Currently it is not fault tolerant. So what we have to do to make it fault tolerant? We have to do nothing but configure a circuit breaker design pattern which says that whenever a particular microservice is down, stop calling that service and rather call a fallback method. That fallback method will show you how to configure it and how to do that. So I'll show you quickly with this particular diagram that how circuit breaker design pattern works. So this is my vaccination center service. This is my circuit breaker. I'll tell you how to configure it. It's a very simple thing. Most of the things will be done automatically. You just have to configure a part. Then you have one user service. So you know I'll show you the code simultaneously so that it is clear to you. So this is my code. Now I'm hitting my vaccination center service, and vaccination center service is internally hitting the user service using the REST template. So it was doing good until unless I actually forcefully closed the server. So that's nothing but a connection problem. It says internal server error, right? In that case, what the circuit breaker do is it tries to hit it at a n number of times. That is also configurable. So suppose I have configured it for 2 times. So it hits, it says there is no response, timeout. It again hits and says, are you up now? Can I get my response now? It says no. As soon as n equals to 2 is reached, it trips. And what does it mean by trip? It is as good as something in your own home also. So if a particular device trips, the timeout is done, the circuit breaks or circuit opens, and as soon as circuit opens, I have to configure a fallback method, and as soon as the fallback method is configured, even if the citizen service is tripped or the circuit is open, it will get its data from fallback method, return to service and return to client, so that at least you have vaccination center data if not citizen service data. So if that much is clear, let me quickly make you go to the circuit breaker design pattern. It's nothing but a way to wrap your API calls so that it can monitor for failure. Now this is too much of theory. Let me quickly show you through the code base first. So let's go here. Our citizen service is already down. Let me quickly close the vaccination center service also so that we can code in this, because the code base is actually in vaccination center service. And from here you are calling the citizen service. So this is the place which is critical. So that is why we have to map this particular method with Hystrix components. So basically there is nothing but a Hystrix command, a way to do that. Okay, so I'll quickly go to pom.xml. In pom.xml, I'm just going to go under my Eureka client and I'm going to add a dependency that I have ready for you, which is nothing but a dependency for Hystrix. So this again is a Hystrix, a dependency given from Netflix to Spring people, and they have wrapped that particular dependency as a starter packages for the Hystrix one. So this is as simple as that. The very first thing you have to do is to add this dependency. Now as soon as you add this, I'm going to quickly Maven update it so that it's going to get all its updated dependencies and jars. As soon as I do that, I am going to go into my vaccination center main file, which is nothing but Spring Boot application annotated file, and I'm going to enable circuit breaker. Great. I have this dependency in place, and I can see that it is here already in place. Though it's deprecated, that is why I said that you should always use resilience 4j, which also I'm going to cover. If you let me know in the comment section that you need to go through that. But this is the very basic and a very important, usually asked an interview question. But how did you use Hystrix and how did you break your circuit? So that's Hystrix for you. As soon as I have done the enable circuit breaker, I have two things ready, which is nothing but this particular application has in the pom.xml the Hystrix command, the Hystrix Spring Boot starter package. That is why I was able to have enable circuit breaker. And the last thing that we need to do is that in this controller, what is the critical section which can break and which needs the Hystrix circuit breaking. So this is the method which needs the circuit breaking. So I'll do Hystrix command, and now this Hystrix command has multiple things. So it says command key, command property, default fallback, fallback method, group keys, and many more. So I'm going to make you go through all this once I have some time. So let's quickly see how to create a fallback method. So I'm going to do nothing but create a fallback method. So I'll say the fallback method and a simple name of my fallback. So let me say my fallback method is handle citizen downtime. Okay, and this method is just going to have the same thing as this. Okay, it's going to give me a response entity, and the name is going to be the one I have given as an input to fallback method, the Hystrix command annotation for this method, which is a critical method where my data can be down, where my data cannot be received from a particular microservice which is down. So as good as that, let me quickly make it larger for you. Okay, now what I'll do is that now I know that may be possible that my citizen service is down, and this particular method is going to be called only and only when my particular user services citizen service is down. Okay, so what I have done here is that I know this method is going to be called only when this particular code fails, only when my REST template is not able to hit my citizen service. Then what I know is that my vaccination service is already up. If it won't be up, this particular method is also not being called. In that particular case, I know that I can at least get the response from vaccination center. As soon as you get the vaccination center response, please wrap up a response entity and return it to users, so that at least even if the citizens are not there, you can at least send this up. Now what you can also do is that you can just save it and you can run it again. So let me quickly run it for you. Debug as Spring Boot application. Let's see the console, whether if it is breaking or not. I should have my Eureka in place. Yes, it is in place, and I can see my citizen service is still down. So what happened was that my citizen service was down, and when that was the case, I was getting internal server error. Now if I try to hit the vaccination center, which is working on port number 8082, I can show that also to you. So it's on 8082. When I hit that particular thing, I can see that, okay, the breakpoint was not there. Okay, I get the response. So I'll hit it again for you just for the debug purpose. I can see that this particular thing is working, but it's going to break at this particular point. So let me quickly do F8 and let's see whether my data comes as a response to it or not. Okay, so if I do F8, can you see my citizen service was down? It was not able to hit it, but still I had my Hystrix command in place, which says this is a fallback method. Please handle my citizen downtime. It says okay. If I am called, that means that at least I am up. I can get my data. I can set the response, and I can at least give you this response entity, which is having at least the vaccination center response. So this is what was required. Now I can happily say that now the system that I have created for you is a fault tolerant and resistant microservice system, because even when my particular citizen service was down, at least I was able to get the data for the vaccination center service. It says citizen is null right now, but at least I have some data. I'm not getting null pointer exception, or I'm not getting internal server exception for you. So that was the beauty of Hystrix. And let me quickly make you go through what we have done. We have gone to POM, we have enabled the Hystrix. The second thing we have done was enabled circuit breaking. Because of this enable of circuit breaking, I found that this is the critical section where my vaccination service is calling the citizen service and it can break. That is why I had Hystrix command annotation which says fallback method is that. Once I have fallback method and this particular thing is down, my fallback method was called and my thing was done. So this was as simple as that. Now let's quickly see how circuit breaker design pattern worked for us. It wraps our REST API call in a circuit breaker object which monitors for failure. Now let me show you what was it. What does that mean? This was my REST API call. So just wrap your REST API call in a circuit breaker object. We have done the wrapping of whole method with the Hystrix breaker. And it monitors for failure. If in interview somebody asks you how it does that, it does internally everything. It actually do nothing but the vaccination center service REST controller is wrapped with a proxy class and it monitors all your calls. So whenever you do this, it makes sure that whole class, the vaccination center controller, is actually enabled with a proxy. And this is not the real controller which is actually calling your citizen service. Is the proxy, and as soon as proxy understands that your citizen service is down, it says that no, I tried twice or thrice, whatever you can manage here. So there are multiple methods to do that. I'll show you what it is. So whenever it says that no, the things are not going right, it monitors it. As soon as it says no, the citizen service is down, it calls the configured fallback method and it's done everything internally. But in case in interview they ask you say that it's done with a proxy class. Now, once the failure reaches certain threshold, the circuit breaker trips. That means the circuit is open and all further calls to circuit breaker returns with an error. Here comes our task. If it fails, circuit is open, configure a fallback method which will be executed as soon as circuit breaks or opens up. So here in our case, our citizen service was down. So as soon as the proxy, which is actually wrapping this particular controller, understands that yes, the particular citizen service is down, please call the fallback method. Our task is to configure this annotation and configure a fallback method which is capable enough to handle the downtime of that particular microservice. So that we have done. The task is done. So that was all about the circuit breaker design pattern. Now, @Hystrix command. You must be asking me, what is this @Hystrix command? It's nothing but a annotation used when you need to configure the Hystrix. So a very simple configuration I have done is a fallback method. There are multiple another things that I've already shown you here before that only. So these were command key, command properties, group key, your thread pool properties. What are the properties of thread pool you need? How many thread you need simultaneously? So basically a thread pool is used to represent a thread pool of Hystrix for monitoring, publishing and caching and other uses. The thread pool property specifies thread pool properties. The group key is the group command key used for grouping together commands such as reporting, dashboard, alerting and many more things. If you want to know about the Hystrix dashboard, please let me know in the comment section. I'll create another video for that. There is also called as command properties, and there are three major properties, that is volume threshold, the error threshold and the timeout. So suppose if I set up a timeout and say suppose timeout is set for like 100 millisecond. So if a particular service does not give me response in 100 millisecond, a fallback will be called. Similarly, threshold percentage, that is suppose 60%. So suppose I hit the user service or the citizen service for like 10 times. Out of 6 it fails. That means 60% failure. And that as soon as the 6th time it fails, the circuit will open. So that's another way to open the circuit. Then here it's another way, that number of retries before the circuit breaks. So suppose I say 5. So if I try 5 times, and if at the fifth time also the circuit, the citizen service is not giving a response back, the circuit will open. So that's the very simple things we have. I'll give this all these things for you to practice in the description. If you find any of the issues in these properties, let me know in the comment section. I've already explained few of them. Now, steps we have used quickly to elaborate. Add the dependency, use this at the main class, use @Hystrix command, and then use the fallback method, configure it according to your project needs. So that's all I have for Hystrix. If you want to know two things, the API gateway and the Hystrix as well, please let me know which you want first and what you need first, because it was like we have done everything on the citizen or vaccination center controller level. We have not done anything on the level where what will happen if vaccination center is down. So suppose if I'll show you what will happen now if I close this vaccination center service itself. So I have made a resilient system which handles your citizen service downtime. But is it resistant to vaccination center service downtime? Answer is no, it is not. After some time, you're going to get connection refused or internal server error. In that particular case, how will you handle it? So the way to do that is the API gateway. So if you want to know more about the API gateways like Zool and others, please let me know in the comment section. Also about resilience folder, I'll also create a video on that also. Thank you.